All right, in this video, we're going to look at working our way towards more complicated trig equations. So let's start with this one here. Cosine of x equals 1/2, and we're expected to give all solutions. So one way to do this is to remember that cosine is the x-coordinate of a point on the unit circle. And if we want that to equal 1/2, then visually we might just go to where 1/2 is. It's about there, we'll say. I'm just going to draw a vertical line to basically indicate, right? Our answers are going to be the angles that correspond with that point there, and then also this point here. All right, so remember I'm indicating this, so this is the line x equals 1/2, right? This is where the x-coordinate is 1/2, so that must mean that this side here I can label 1/2. You zoom in on it. This is the unit circle, so that hypotenuse is 1, and that makes this the y-coordinate √3/2, which tells me, since this is a special angle, a special right triangle, I know that this must be here 60 degrees. Okay, and by symmetry, again, this is the unit circle, so that's 1. This would be negative √3/2. So that angle there, the reference angle is 60 degrees. Of course, in standard position, we would call that negative 60 degrees. So this gives me my answers. I have basically two families of answers. The first family comes from the angle in quadrant 1. I'm going to use radians here, so 60 degrees is pi/3. And of course, if we just rotate multiples of 2 pi, we'll just keep getting coterminal angles there. So all of those angles would be solutions, since the x-coordinates would be 1/2. So this is basically the first family of solutions in quadrant 1. And the ones in quadrant 2, quadrant 4 rather, we can just use negative 60 degrees or negative pi/3 as a beginning angle, because we're giving all solutions as long as we add multiples of 2 pi. We'll have described all of them. So I'm going to just describe that angle as negative pi/3 plus multiples of 2 pi, and you want to ensure that your n there has to be an integer. Okay, so that gives all solutions. Let's apply this idea to an equation where the b value is a little is different than 1. Okay, so for instance, let's say we had to solve cosine of 3x equals 1/2. So what I want you to do is first just turn this problem basically into this one. And to do that, we're going to make a substitution. So let's just, for the moment, call the 3x something else like w. Okay, so now I'm solving cosine of w equals 1/2. And I've basically done the work for this already, because if you look above, right, cosine of x equals 1/2, cosine of w equals 1/2, you're going to have the same solutions. So I'm going to describe them over here. We know that those two families of solutions are w equals pi/3 plus multiples of 2 pi. And then the other family is negative pi/3 plus multiples of 2 pi. Now, of course, we just got to remember, we weren't really solving for w, we were solving for x. So we substitute that back in for w. So this means 3x is equal to pi/3 plus 2 pi n. And of course, this means 3x is equal to negative pi/3 plus 2 pi n. We divide both sides by 3, and we'll have our answers. So I'm just going to kind of indicate dividing those all by 3. Okay, so that gives me x is equal to pi/3 divided by 3 is pi/9. 2 pi n over 3, let's just think of that as 2 pi/3. 2 pi/3 times n. And of course, same thing here. This will be x equals negative pi/9 plus 2 pi/3 n, where n is an integer. Those are all my solutions to the equation cosine of 3x equals 1/2. Now, sometimes you don't want all solutions, or you're instructed not to give all solutions. And let's just say you wanted just the solutions on intervals 0 to 2 pi. So to do that, let's just take our family of solutions. Let's call this, let's call the first family this one, pi over 9 plus 2 pi over 3 n. Let's just start plugging numbers in for n, and we'll stop once we've exceeded the range there, the interval there where they want our answers. So if n is a 0, then x is going to be pi over 9. Okay, when n is a 1, I have to add pi over 9 plus 2 pi over 3 times 1. So here, I'm going to, just to make the mental math easier, let's do two things. First, let's describe 2 pi over 3 as 6 pi over 9, right? It's an equivalent fraction. Now, when I times it by 1, it's just what it is, 6 pi over 9. So when you add those, you get 7 pi over 9. Okay, when n is a 2, that would be 2 times 6 pi over 9. That would make this a 12. And so I get 13 pi over 9. When n is a 3, this becomes 6 times 3 is 18 pi over 9. And I get 19 pi over 9. But notice 19 pi over 9 is greater than 18 pi over 9, which is 2 pi. So we've already exceeded the interval, so we don't care about those answers. That was all from that first family. Let's now do the family that comes from here. I'll just move this. Well, I guess we don't really need that anymore. I'm going to erase that. Let's do the other family. X equals negative pi over 9 plus multiples of 2 pi over 3. So again, let's start with 0. When n is a 0, we get negative pi over 9 for x, but of course that's outside of our window, right? Our interval starts at 0, so we don't care about that. When you plug in a 1, you get negative pi over 9 plus, and again, let's think of this as 6 pi over 9. Negative pi over 9 plus 6 pi over 9 is 5 pi over 9. Okay, we plug in a 2. 2 times 2 pi over 3 is basically going to multiply that. 6 times 2, you get a 12. Negative pi plus 12 pi is 11 pi. 11 pi over 9. And when you plug in a 3, this becomes 18 pi over 9. Minus 1, you get 17 pi over 9. Now you can plug in 4, but we look at 17 pi over 9 is just 1 pi over 9 shy of 2 pi. So the next plugging in 4 would exceed our interval. So these are our answers. I'll just highlight them in yellow. Those are 3 there, and those are 3 there. And we're just going to indicate, maybe we'll indicate it like this. Our overall solutions, I'm going to write them in order, are pi over 9. And then the next one is 5 pi over 9. And then the next one is 7 pi over 9. And then the next one is 11 pi over 9. And then the next one is 13 pi over 9. And the last one is 17 pi over 9. And those are all our solutions. Let's go just check with the graph to make sure that this was working. So I've got here cosine of 3x on the interval of 0 to 2 pi. I've got 1/2, and you can see the intersection points, pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. Those are all precisely what we got here at the bottom. So it worked. So again, maybe just a couple things to point out. The substitution business is very important, and in a future video, we'll be doing that more to turn more complicated trig functions into simpler ones. Also, it's usually easiest to describe all solutions first, like I did in part A, and then move on to whatever interval you care about by plugging in the appropriate n values. All right, and obviously this is all rooted on your basic trigonometry and unit circle knowledge. Hope this helped. I'll see you in the next video.